Okay, so, well, nice small class. Don't be bashful about asking questions. So let's go through the homework assignment. So the first one was to take this list of numbers. Bring up. And to take these numbers which represented characters and then create a string out of them to see what those characters represented. And so we're going to read in this list of numbers here, and when we read this in, we're going to be reading this in as a string because it's got spaces in it. And what we want to do is to take that string and be able to then separate out the individual values and then convert the values into numbers and then see what characters each one of those numbers represents. So my solution ahead, we're going to input enter the coded message, and it's going to be written, it's going to be put into a string variable codes. And then what I want to do right off the bat is I want to be able to take each one of those values and separate it into an individual element and perhaps put it in a list. And as we saw in class on Monday, that if we have a string and we want to split out the individual elements, we can use the split method. And if the values are separated by spaces, I don't have to pass any parameter to the method. And the split method will take the values in code and then separate and then create a list where each element of the list is going to be one of the values separated by a space. And so what I should get out of that is the list 76. In the list, we should get this many values. Each one of those is going to be a string, however. Okay, that's still fine. But now at least I have the values separated out and they're in the list. And now what I want to do, or at least my solution was, is to go through each element of the list and convert the element of the list first from a character to a number and then from a number to its character equivalent. So I want to go through each element of the list. So I used a for. So my for loop is going to extract each element of the list. And now what I want to do is I know what I want to do is I want to take the value in the list. So that is going to, which is going to be represented by code, but code is a number. So I know I'm going to have to convert. Code is a string. The value in code is a string, so I need to convert that into a number. So I'll call the int function. And then what I want to do to the int after I turn it into a number is I want to turn it into its character equivalent. And we learned in class that the CHR function turns a number into the character value that it represents. That gives me the character that value in the list represents. And my solution was, well, what I should do is simply take each character and build up my string character by character. So I'll have the variable outString, which is simply going to be equal to outString plus that character. Right, so I should initialize out string to be, so the null string, because I can't have it on the right-hand side of an assignment statement unless it's been initialized. So I'll initialize this to the null string, and then I'll simply go through the list character by character, converting it from a number, from a character to a number, and then taking that and then converting it into a character, and then appending it to the list that I'm building up character by character. Just to wake you up. Me too. Oh, and it would be nice if I printed it out. Well, that one was live long and prosper. I didn't do the Go Pirates, so, but well, that's pretty cool. Okay. So, any questions on that? Anybody do it differently? Jordan?
I guess the way I did it was really like drawn out, but I wanted to separate the functions so that my main wasn't as cluttered, and I had a decoder. I had a decoder function, and I made an array in it called line, and then I had I took sentence from main, and then I put for x in the range of the length of the sentence split, append that to line after you've done the whole character function.
This function here, the CHR?
Yeah, so basically like appended it. I did that, but like with the append function.
You use the append?
Yeah.
And you created a list?
Yeah.
Did the same thing, and then at the end, instead of printing like outstring, I just did a join of that new list.
Exactly.
Yeah.
So that's cool. How many of you did that?
It's kind of like extra work because you split it, and then you just joined it again at the end.
And it's like 2 4s instead of 1.
And then you put the...
Well, you could have, so you did, so you guys did, so you created an empty list. So you created, so you had this other list that you initialized to nothing, right? And then you did, here you did, so you appended that. Okay, so now what's happening is so now for people, looks like everybody did it this way. Okay. Oh, you didn't. You did it my way? This one is clever because now we've taken each individual element, we've created this list LST, and now we can use the join method to join LST, right? So remember we had split and join, so now we're joining, not putting anything between it, the values. And that works good also. So that was good. You guys got to exercise the join method by taking the lists. Okay, and So the other one, okay, so it's good to see different solutions. So the other problem was to take the date and to break it apart, to take the numeric version of the date and take it apart so you print it out as a word, comma, the day, comma, the year. And so my idea was we're going to
Bless you.
enter the date and put it into the variable date. And then what I want to do is I think I said you wanted to create a function that's going to break it apart. So I was going to write a function called extract and pass it the date. So that's going to take the date and break it up into the individual parts. And then after I extract the date from the individual parts, so that's going to return to me, I think that's going to return to me, well, let me just think about how I was going to do that. So for this, I now know that the date is going to, the different parts of the date are going to be separated by slashes. So again, if I want to now extract out the month, the day, and the year, I could again use the split method. In this case, the space isn't the character that separates different values, it's the slash. And so now I'm going to break apart the date into three different parts. They're going to be characters. I'm going to put it into the list date parts, and I'm going to return date parts. So now I've got the elements of the date in a list, which gets returned to me. And now date parts has month as the first element, as character, day, and then year. I should have said this was 4 characters. And now that I have that, okay, so now how am I going to convert this? Well, I need to take the date and turn it into a month. And let's just assume that it's valid, that the month, the first value is going to be between 1 and 12. So how am I going to translate a 1 into January and a 2 into February and a 3 into March? I could have had a giant if statement. Okay, how many people used an if statement? That's fine. It's only 12 things you had to type in. Another way to do that is to say, well, if I had a list of months, okay, I'm tired. I'm not going to type everything because I'm lazy. Type these 4, but I could have typed them all in. So if I had this list of months, then if I take the month and convert it, if I take this they typed in and convert that into an integer, I can then use that as an index into the months list, right? So if this was 1, was 1, then the month would simply be months, bracket, and in this case it's going to be date parts, but I've turned that into an integer. It's going to be date parts, bracket, 0, bracket, because the first element of date parts is the month. Right, so this is just a snippet of code here, but if I wanted to now try to translate that number into an index into the months, I simply take the month. So, very good. So let's suppose I'm not sure this is going to work and I want to sort of build this up. So I said, well, let's see if this works. Why don't I just run this and print this out and see what happens. So if I run this, die. problem. Okay. Now there should be two. Anybody see anything? Oh, hold on. Sorry, hold on. No, it's bracket, that's right. Fine. Before I shake you up again. So that closes that, and that closes that.
After 0, I think there's a round bracket and then a square bracket.
Into that, right, thank you. So if I were to type in 11/20/19/2019, I got an error here, index subscript out of range, and this should be 11, so day part should be 11, so I'm taking months of 11. Oh, I know why, because I only typed in 4 months. So let me run this again and give it a date. So if I were to type in February 21st, 2019. Well, okay, so now I've printed out March, okay, so that's not quite what I wanted. If it was 2, it should have been February and it printed March. Why did it do that? Well, the problem is, as Nimra pointed out, that the indexing starts at 0, not at 1. So if someone enters a 1 indicating January, I've got to translate that 1 into a 0. And similarly, I should have translated a 2 into a 1 to get February. So in fact, what I should have done here is subtract 1 from that value. So whatever the month was, take its numeric representation and subtract 1 from it, and that should now give me the date. And so now if I do that, it in fact now printed out February. Sorry? Okay. So now that I've got the month out, that seemed the hard part of it. Now all I need to do is to now put together the other parts of it. I'll put a comma there. And so now I'm just adding in, after I did the month, then I'll take the day, and then I'll take the year. And now it prints it out properly formatted. So you could have translated the month by using an if statement, if else. Or another way is because the month numbers translated nicely into indexes, with the exception I've had to subtract 1 from it. I could have used this trick to simply type in the months. I guess it was less typing. I'm not sure there's any better way to do this. Anybody get any else? You had to use the split to get the different parts out. And you either determine the month, I guess, by doing an if statement or by using this indexing into a list. Anybody else? Chris?
I mean, nothing really drastic. I did what you did during the lecture, in that I put all the date values into, essentially, like, I assigned all the variables using the commas, and then I was able to pass it from the parse data function or the extract data function
Got it.
back down into the main function. So during my print statement, I could just say month, day, and year.
Yeah, return to
Yeah.
Oh, very good. A little,
You told us that in the assignment.
oh, I did. I said, well, you know what, actually, that's funny you should say that, because I read the assignment last night, I actually did it. And I read that, and I said, well, you can interpret that, did I say 3 separate?
You said the package, you know, the split function to the main function. I think.
Okay, so let's get our legalese hat on here. This called function should return these 3 values to main, which should then do the remainder of the task. So I did that, but I did it by sending it via list. But how many people send it via list? Okay, so apparently, Katie, we're in the minority. Okay, fine. Another way to do this would have been simply say, date, this is what you guys do, date part 0, bracket, date parts. I'm happy you guys did this. I'm not criticizing them. And you sort of read what I wrote. And so now, if you recall that you can pass multiple values back from a function to where it gets called, and now if you did that, here you wouldn't be passing back a list, but you'd be passing back 3 distinct variables, and you could have passed this back into I'm calling this comma, dd, comma, yy. And now the variables dd, yy would have been the individual parts, and then you wouldn't have had to extract things out of the date parts list. So that's good. I'm glad you guys exercised that.
And you can also do like MMDDYY equals to data split. I think that's how the one you told us last time.
So you did. So this would be the string 2/21/2019 dot split. So since split returns, wow. Okay. So Nimmer did it better because she did it 1 line shorter. If you saw what she did is she just took the output of the split method and dumped it into the 3 variables. And so you could have just returned that. Okay, very good. So, right. So we're going to do, so a new idea for today. So how many people are getting more comfortable, how many people are still uncomfortable with functions and prefer that they never existed? Hi, Katie.
More comfortable, but not.
You're not completely comfortable. You still find them more of a hindrance than a feature.
Yeah.
Okay. That's okay at this point. Okay. I'm glad you're finding them more comfortable. I guess you don't. Hopefully you find them at least useful in terms of, let's say, breaking out, doing the input functions, inputting values and doing validations. It seems like that would be a natural break. So today I wanted, okay. So I want to do one more thing with respect to learning about how functions operate. And I think it has a happy ending in the sense that what you're going to learn is going to be easy to use, and I think make functions, it's going to be easy to use this new facility, and it's going to make functions easier to use. Okay? And this has to do with passing values back and forth between one function and another. So to set the stage, and this, what I'm doing now is not new, it's by way of review, and I'm guessing everybody's going to get this, but why don't we just set the stage? So suppose we have this program here. We have these three functions, func1, func2, main, and main. And just to make sure everybody's on the same page, let's go through what happens with the different variables as we go through this. So main gets called, and the variables A, B, and C get initialized to these values. And if I run from, and in main, now if I print out A is equal to what? If first main A is equal to, well, of course, it's going to print out 8 for A. Everybody's in agreement, I'm assuming here. I then call the function fc1, and I pass it as a parameter the value b. So fc1 takes as a parameter here, it takes one parameter. Now note here, I'm doing this on purpose to be a nuisance, but just to test your understanding of it. Func1 takes the value of b, which is 9, and it passes it, main takes the value b and passes it to func1. And func1 now creates a variable called a, and what does it initialize it to? It initializes it to the value of b, which is 9. So going forward in func1 now has a is equal to 9, so now we take a, which is equal to 9, multiply times 6, and now a is equal to 54. And when I print this statement now, a is equal to 54. Agreed? And now I return the value of a, so now I come back here, and func1 returns 54, so the value of 5, which was 5, the value of c, which was 5, now is 54. Right? It's confusing on purpose because I'm using the same variable names in the different functions. We typically wouldn't do this, but I want to make sure you guys understand it. So now c is 54, and if I were to now print a out, what is going to be the value of a at this point? We got an 8. Right? Panos says it's 8. What happened to the value of a over here that was 54? It's c. Does a exist over here anymore? It's dead. So 54 is gone. So Panos is right, it's 8. So now what's the value of c? 54. I now call func2, which doesn't pass anything. And func2 initializes these variables, b to 12 and a to 24, and now a becomes 2, and we print out func2, and now a is equal to 2, and b is equal to 12, and now that function returns. So now what's the value of a in the main function after func returned? Notice that func did not return any value, it doesn't have to. What's the value of a at this point?
8.
We got an 8. It's 8 because it was 8 here and I didn't change it, and the fact that the func2 had a variable called a is irrelevant because these variables don't have any impact on these variables here. Okay, that was confusing, right? But everybody sort of got it, right? So a computer term you should know in terms of programming is, okay, we know about variables, they hold values, but variables can be broken up into two different kinds of variables. In addition to, variables can be broken up in that they hold numbers or they hold strings. But another way to differentiate variables when you're dealing with functions is that these variables, the word here is local. So the variables a, b, and c are local to main, meaning that these variables exist in main, a, b, and c. And the variable a, which is different than this variable a here, exists in func1. It's almost like these are houses and these are names of people, right? So there could be a house with the name of somebody called Joe, and there could be another house with a person named Joe, and those two people, Joe, are completely different because they live in different houses. That was pretty good. I did that on the fly. Get it? Right? And functions, just like people, can call They can name themselves or name their children whenever they want, and obviously it happens that they give them the same name. So variables, there is a variable can be local to a particular function, which means that that variable only exists within that function. It has no impact. Another function can't mess with it, and a variable in another function it can't mess with. It just is local to that particular function. It exists within that particular function. It can be changed within that particular function, but that's it. It has no impact on any other function in the program except when that function is running, which everybody seemed to get. Okay, so fine. Okay, so for the next 3 or 4 minutes, I'm going to talk about variables and functions again. I want you to listen to it. Don't turn me off. For people interested in programming, you need to know this idea. I don't particularly like it. I would never use it when I'm programming, but you need to know it because people would do it. This isn't a happy ending. I'll give you that. We're having a build-up here. So let's take a look at this function here. Let's take a look at what we have here. So I have main, and I have a variable x, and I have a list called nums, and I call f1, and I pass to function 1, and I pass to function 1 x, the single-valued variable, which has 1, and nums, which is a list. So here in func1, x is equal, it creates its own variable x. Here it creates a list not called nums, but called vals. And now x here, what do you think would print out here? Well, x would be 1, and when you print out vals here, vals would print out the values in nums, right? Because when you get called, when the function gets called here, nums gets passed to vals, so val assumes the values of nums, and it just prints it out. And when we return from here, nothing has changed. Func1 hasn't changed x, nor has it changed nums, and so these should be the same as they were set. So this isn't anything new, except we're passing as a parameter to a function a list. Okay, nothing new there. Okay, here's the rub. If you're going to do program in Python, you should know that this exists. So I've got almost the exact same program here. I've got a main where I have an individual, I have a variable x, and I have nums, which is a list, and I call it to func1. And now I set in func1, I set x equal to 555, and then I set to vals, the first element in the list, vals to 555. So that's what func1 does. And now I return, and what would you expect x to print out here? So x was a local variable, and it was set equal to 1. What do you think it's going to print out here? 1. That would be the right answer. And when I print out nums here, what would you expect would print out?
1, 2, 3.
And you would be right in saying 1, 2, 3. In that's what I taught you. But that's not what happens. Okay, so here's the rub.
Did you not return any values though?
I did not return any values. So why are you saying, wait, he's lying to me? Okay, now you're going to sort of distrust all the stuff I've taught you all semester. He's lying to me. He told me that when you change a value of a variable in a function, it doesn't do anything to the variable from where it got called from. Except with lists. So Python treats lists differently than single-valued variables. So in fact, what would happen here is that any change I made to vals, which is really the same thing as nums, is going to be permanently made to nums. So in fact, when I change vals here, the first element of vals to 555, I was actually changing the first element in nums to 555. And so when I print this out, when I print nums out, what it's going to print out is the list 555, comma 2, comma 3. So the takeaway here, and I know people, I'm happy that people are getting better with functions, and this is something that you sort of need to see so that you won't be, if you were to go on to this and try to do more Python programming or get somebody's Python program and say, what the hell is going on? So the deal here is in the box is that when we pass a variable to a function, it's either an integer or it could be an integer, that when you change that integer in that function, it does not get changed permanently from where in the variable where the function was called. However, lists are different. The computer science word for list are passed by reference. Don't worry about the term reference. All it means is that when you change the list in the function, when it gets returned, that change is permanent and that list has been changed. So Python treats integers and floats differently than the way it changes lists. This is again, it's a data point that I want to give you. I don't think there's much I don't know. I haven't done enough Python programming, so maybe there's utility in letting them do it. It doesn't make any difference. This is the way the language is defined. Yeah, Surya, yeah?
How does this help us? Like,
What's the value in that, right? Why are you bothering me with this? I'm going to come back to that. I don't think, at first blush, I don't think, a couple of things. So I don't think this is a great idea. If you wanted to change the list, note that if I wanted to change the list here, what I could have done is I could have passed back a different list. I could have taken this list, changed it, if Python didn't want to allow that you can change a list, and simply return the list with a changed value and I could have created a different list here and put 555 equal to the first element of the different list and then say return the list. And then I wouldn't have had to give you this lecture on that list behave differently than single value variables. I guess, okay, so the answer is, suppose you have this, suppose you wanted to pass back a whole lot of values and you didn't want to have a comma separated like you guys did for homework. Then you could just dump it in a list and then when the list, and pass it as a parameter and the calling program would have gotten it. That even is not such a great, because that's terrible. I don't really, okay. The real answer is, okay, so the real answer is that the way Python stores things in memory, it obviously has to somehow store these different values, 1, 2, 3, 4, and associated with the variable nums, right? And this list could be enormously long. So in the case of a single valued variable, when a function is called, when main calls func1, and it's a single valued variable, what Python actually does is it takes that single valued variable and creates another memory location and says, okay, I'm going to copy that value that's in X into this new variable location. And now func1 is going to deal with that new memory location. It could do with it what it wants, right? And then when the function ends, that memory location is gone. But when it takes lists, Python, when you implement a list, they say, gee, if I have this list that has 10,000 elements, am I going to copy 10,000 elements? So instead of copying the 10,000 elements, because lists can have more than one value, instead of creating a copy of the list, it simply passes to F1, func1, not all the elements, but the location, the beginning location of the list in memory where this occurs. So it has this, so now func1 is not working on its own copy, it's working on the location in memory that main has. So to some degree, it's an implementation issue with respect to Python and how it handles lists and what are called pointers. And so it's passing the pointer to where that is in memory, where that list location is.
So let's say that the list, like nums, was compiled using, I guess, like user input, and like you had to make like a variable like x, and then ask for input for x. If you were to change like the vowels like you did here in the first position, would it also change like what x is in the main? Like if you had to input like x is like the first position in nums, and then you change the first position in nums, would it also change like x?
No. You're saying you had a variable x, which is holds some position number.
Right, if you made like, because nums and x are the same, like the first number in the list nums is 1.
Oh, they're different.
If you got it there using like x, I'm saying.
Oh, no, it wouldn't go back and change
Okay.
x, because they're different memory locations. Okay, so that's a bit of, again, if you didn't get it, this whenever you this is stupid, that's fine. But I felt compelled to show you this because it is an element of Python. I think, just indulge me for a minute. Yeah, I think it's going to be upset. Actually, I think this is going to give me an error. I hope it does. So I want to see if it treats strings the same way that it handles lists. So I'm going to create a string. I'm going to pass the string to the function. I'm going to change that value. Note that the variable names are different, but who cares? I'm surprised. So it treats strings the same way it does integers. Okay. Thought it was a pointer. Okay, so now let's get to the good stuff. Let's get to the thing that has utility. So I said that variables can be of one type. They can be local, and they just exist within that function. Okay, everybody listen to this one. Or a variable can be global. So variables can be either local or global. And a global variable is a variable that exists for any function to be able to access and change. So I was making a big deal in saying these variables exist within a function. The function can look at them and change them, and once that function goes away, with the exception of lists, those variables only have a life and only impact that particular function. But it could be, what if you want to create a variable and you want that variable to be passed around to lots of different functions. The different functions can now access it and change it. You're writing a big program and you have a bunch of values that every function needs to be able to look at and change. Now, one way to do that would be to pass the variable to each of these functions, and you could certainly do that, and that's actually a pretty good programming technique. But as an aid to writing programs, someone said, geez, isn't there a way to just have this variable that everybody needs to look at, every function needs to look at? Again, let's take the scenario that this whole class is on a project writing a big program, and everybody has a different part to write the program, and everybody's going to need to have access to this variable or these sets of variables to be able to look at them and change them. And as opposed to having to go and pass them back and forth when functions get called, when my function calls Nimra's function, instead of me having to pass that variable to her and have to remember to do it and her function has to take it, can't we just all agree that we can have this set of variables that everybody shares? They're global to every function. And so hopefully you're going to see that should occur in large programs, that they're going to be variables that everybody has to have access to. And those things are called global variables. And to create global variables and to use them is not that big a deal. Okay, So I wrote what they are. Let me talk through it, and I'll go back and reinforce this again. So I wrote this code. If you want to download it, just go to Blackboard. It should be in the last content entry, wherever we're up to. There's only one. It should only be one thing there. It should be called. Die. Okay, so here's the code that is going to show you this, the mechanics of how this works and what you have to do. And there's not a lot you have to do to actually make a variable global. So I have here, again, don't type this in because you can download it. So I have here a main routine and two functions called decrease and increase. So all this stuff, with the exception of this word global, is not new to you. And what I want to do is the main routine and the two functions increase and decrease need to have access to this variable, in this case two variables, all the time. And so instead of passing it back and forth between functions or returning things, I want to make these variables global. And the two variables are the variable x and the variable count. So I have a variable x that I'm going to be increasing and decreasing based upon the function calls to increase and decrease, and I will have the variable count that's going to count the number of times that decrease and increase is called. So mechanically, if I want to have a variable that is shared amongst all the different functions, I need to do two things. First, I need to initialize the variables before I have any function definition. So global variables are defined by initializing them to a value. If I had a list, I would initialize the list to being nothing. So instead of initializing a variable within a program, within a function, I'm going to initialize the variable at the top of the program. The key here is that the variables don't exist within any function. I have a slide that goes through this, I think. So I'll go through this a couple of times. So let's just watch first, and then you can. So if I want a function to be able to use those variables, the only thing that I need to do is I need to incorporate at the beginning of my function the word global. So this is a new Python term, the word global. And after the word global, I need the variable names. In this case, you have to call them by the real variable names here, x and count. You obviously can't call them something else. They have to be the name of the global variable. So the way this program now is going to run, let's trace through it, is actually now the first thing that happens is actually a variable called x is created, initialized to 100. A variable count is created, initialized to 0. And now main gets called, and so now I come into main, and the main program says, hey, guess what? I want to tell you, I'm stating my intentions that I want to have access to and be able to change the variables x and count. So I simply say global, telling Python, I need to have access to x and count, so I include the statement global x and count. Now when my program runs, the first statement says print main start value x equals to what's the value of x? Well, x is this global variable, and it was initialized to 100, so x is 100. So note I didn't initialize the variable x in the function main. The fact that it is a global variable, Python says, oh, let's go to the global definition of it, which is 100, and now it retrieves that as 100, and that's what main is going to use in its program here, so x is 100. I now call the increase function. Now notice I'm not passing any value to increase. I'm simply calling the increase function. And the increase function also wants to have access to the variable x and also have access to the variable count. So it too includes the statement global x and count. And now it has rights to be able to use x and count. And so now, with not having passed x to increase, simply by making this global statement, x now is now whatever the variable x is, which is still 100. So I'm going to take 100, add 1 to it. Now x is 101. And now I'm going to take the variable count, which is also a variable, and it's initialized to 0, and now count is equal to 1. And now count is equal to 1. And now the function increase exits, and now I come back to my main routine, and now I want to print out the value of x. So what's now the value of x? Well, the value of x now, okay, because it's a global variable and has changed by the function increase, now reflects what increase did to it, and so that would print out 101. And it would print out for count 1. And let's say I call the function increase a second time. So when I call it a second time, okay, increase is, let me go get the value of x, let me go get the value of count, and now x is equal to 101, and so I'm going to take x, add 1 to it, now x is 102, take count, add 1 to it, now count is now 2, and now I return, and when I return, x is 102, and count is now 2. And then, just to show that it's not restricted to one function, I'm going to call the decrease function, which is equivalent to the increase function, except instead of increasing x, I'm going to decrease x, but I still have to use my global statement, and I'm going to take x and reduce it by 1, so x was 102, I'm going to reduce it by 1, now it's 101, and count was 2, now it's 3, and when I return from here, now x is equal to 102, and count is equal to 3. Okay. Anybody have any Nick?
So you can't have like a non-global variable with the same like name as a global variable, right?
Did you really have to ask that question? Okay. So, okay, everybody watch. So as Nick is asking, could I in fact have in one of these functions, let's say the increase function, a variable x that wasn't global? That's what he's asking. It's a bad, annoying, insightful question. So suppose I just had this. And we said x is equal to 57. So what do we think is going to happen here? If I were to go out here and now and run this program, when I call increase, so now here, so I have this global variable x. Okay, so let's run through this. I have a global variable x that says equal to 100, counts equal to 0. I call main here, so x is equal to 100. I now call increase. Now increase here says, I don't care about the global variable x. I'm creating a variable x here by myself. I'm setting equal to 57. Is x here, everybody, a global or a local variable? Local. It's local. And so Nick's question, which was annoying, is that can I in fact have a variable name, can I have a variable that is both global and local? And the answer is yes. And in fact, if I were to run this, hopefully I didn't type anything wrong, we see, in fact, it ran, and so when it ran, it started off with x being 100, but when it called increase, notice when it came back from increase, x was still 100, because I don't have x as being a global variable, I have it equal to being local. So when I made this change here, when I took 57 and I added 1 to it, it made x 58, and then increase died. Notice that count was fine. It was happy. Count was being increased, 1, 2, 3. Because that was a global variable. But the variable x here was local to increase. And therefore, it could do whatever it wanted, but when increase exited, when increase finished, the local variable x died. It had no impact on the global variable.
So you would have to return it in order for it to work in that function.
Correct. Okay, now, you would have to have your head examined to name a local variable the same as a global variable. You're asking for trouble. I know that that's not your point, you just wanted to see if it was possible, and it is. But you would just be, the reason you'd be stupid to do it is you'd be confusing yourself, or anybody else who's trying to read the program, because now they'd have to figure out if it's local or global. And why would you want to do that? You could have come up with any variable name there that you wanted if you wanted to do some calculation where you didn't want that variable to stay around afterwards. But the truthful answer to your question, Nick, is that in fact you could do that if you wanted to. Okay? Okay. So, I at the beginning of this, talking about this new idea about variables and functions, I said I think this has a happy ending. I think it has a happy ending because and I'll show you one other thing, Nick, because you seem interested, and I need to show you that. But let me get through this. The happy ending here is as follows. If you buy into using functions, and if you want to write them with having to necessarily worry about passing parameters from one function to another by including them in the parentheses, then you can easily do so by simply, instead of having to do that, create global variables and simply have the statement global and the name of the variable and the functions, and you don't have to worry about passing variables back and forth. So it does provide a and the whole point is this is how we have functions be able to work on the same data, how you get data to functions to work on. The original way I taught you was you pass parameters in the parentheses, and that's how you communicate from one function to another. And the function can return a value, or the function can return multiple values, or the function can return lists. And so that was the primary mechanism for functions communicating values back and forth. And I will say that it is the preferred way of doing it. But this is engineering, so I'm going to be philosophical here. So what's the difference between engineering and science? So engineering says, yeah, that's fine, but there are going to be cases where this is one or some subset of variables that everybody needs, and it's just going to be a nuisance to pass them back and forth. Why don't we sort of break with this righteous, we should be passing just values back and forth, and judiciously, not a lot, but for those variables that need to be available to everybody, we'll create this mechanism called global variables. Of course, it could be abused where every variable could be a global variable, and that would be bad programming practice. But used judiciously, sort of engineering, this is a practical compromise we're making for the greater good, this seems to be a good idea. If you were to go, if this were a computer science class and I'm teaching pure computer science, global variables are typically frowned upon. And they're frowned upon because the problem with a global variable is, when I gave you this introduction, I said the whole class is going to be working on a project and they're going to need access to these variables. Well, that's nice, and so that sort of made sense. But what if there was somebody here who's a bad programmer and kept screwing up one of the variables? Well, that would impact everybody else. And we'd have to try to track that down as to where that was. If everything was local, then what they did wouldn't impact somebody else. It'd be much easier to find the problem. And that's why global variables are typically a bad idea. So there are mechanisms within these programming languages which allow you to do things. They can be abused, or they can be used to help you write programs for yourself that work better, or to write larger programs. So global variables, the existence of global variables doesn't say we don't need to pass back values back and forth. It just means that sometimes we're just going to say, you know what, I don't want to pass this one back and forth. It is such an important value that I'll let everybody have access to it. And so that would be a reasonable use of global variables. Okay, does everybody get that? So this is just in place of or in addition to passing values back and forth from functions or returning a value. It's another communication mechanisms between functions. So the takeaway from today, okay, I think what I just said is the takeaway. Your understanding of global variables, which is not very difficult at the idea, I think that's the takeaway from today. The idea when I talked about lists, when a function changes a list, I don't think that's an important takeaway because I wouldn't use it, right? So at this point, you should get the idea of programming as sort of like you're a craftsman, and you've got this box of tools, and you have hammers and saws and awls and all these different types of tools. And in programming, we have for statements and functions and returning values, right? And we have all these things at our disposal to try to solve a problem. Just like a craftsman can use a tool improperly, like taking the end of a screwdriver and using that as a hammer. That's not a good idea. You can get it to work, but it's not a good idea. You can use elements, these capabilities within programming language improperly. The programming language can't enforce that you're doing this in a good way, but they're just good programming. They're good programming practices. Okay, so I don't want anybody to leave, but that's sort of the end of my lecture for purposes of what I think you should know. And the one takeaway is the global variables. I did introduce the list thing because I wanted you to see it, not necessarily know it, so that if you were to go on and you would see this in somebody else's program, you would know what the hell is going on. In that, and I don't like it, in that same manner, this annoys me. Okay, ready? So, how am I going to make this simpler? I'm just going to write a new program. It'll take about a minute. Okay, take a look at this code. Don't copy this down. I just want you to see what Python does. Okay. So I have this global variable x, right? It's defined not inside a function, so it's global, or it could be global, assuming, wait, I have to do this. So main says, yep, I want to get access to x, so I say global x, and I say main. And so you would think that x would print out as 100 here. And then I call f1. And note here in f1, I don't say global, but I reference x. And you should immediately say, so let's run this. So you should immediately be annoyed because, well, I'm annoyed because I hate lying to you, and it seems like I did lie to you because I'm calling f1 and I'm referencing in f1 the variable x, but I didn't say global x. And what I told you before was In order to reference a global variable, like I did in main, you have to say global X. And yet in F1, I don't have the statement global X. But Python didn't mind, as you'll see, that Python actually printed out in F1 that value was X, was 100, right? What you should expect was that I should have gotten an error because I'm referencing a variable in F1 X. I'm referencing the variable X in F1, but I haven't defined X in F1. If I were to take this program, everybody watch, if I were to comment out this line, okay, and let's suppose this would give me an error here, and I would say X is equal to 3, and now run this. Note that I get what I expect. I get an error from the function F1 because in F1 I'm referencing the variable X, but I've never defined X. And even if I left this, strike this out, if I left this, well, let's see now that if I left it, now let's see what happens. Now when I do that, now it's happy because it says X is equal to 100, but I don't have any global statement there. And I had told you in class that if you want to, in a function, reference a global statement, you have to have the statement global space X. So what is the real story? So I'm just saying now in X, you should say, okay, fine, he took X and he added 1 to it. I really didn't change it very much, right? Well, now when I run it, I in fact get an error. Now it's not happy, and it's giving me an error in F1. Okay, so here's the I can't imagine the motivation, and that's why I told you the other way. So the deal is, if in a function you want to simply look at a variable, retrieve its value, but not change it, you can simply reference the variable name like I did before when I had when I just did this. And Python won't mind. Python will say, oh, he wants to reference X. He's not defined X in here. He probably means the global variable X, and I'm going to give him access to it. So it'll print out. But if this person wants to change it, you can't do it. If you, in fact, want to change X, what do you have to do? You have to say global of X. I can't imagine why you would design the language that way. So I've redesigned the language for purposes of this class. So you needed to see that, I guess, because if you looked at other Python code, you won't be mystified. It seems sort of dopey to me that you can access a global variable but not change it without having to say the global X statement. They sort of now they sort of have an intermediate form of a global variable. There's a global variable that you can look at but can't change. Okay, you can just use it and you just reference the variable name. Or if you want to actually have a global variable in your function, use a global variable in your function that you can change, then you have to have the global statement. It seems like a stupid way of doing it. So I think for purposes of our programming, let's just say we'll always put the word global and then the variable name to state our intentions. We want to access it and change it. But that is not the actual definition of the language. Okay? So I'm showing you that. I don't think there's any point in you using it, but for completeness in terms of teaching you the language, I have included that. Is there any question on that? I know I said a bunch of things where I take things back. I'm trying to be sensitive to the fact that the functions are difficult in passing values back and forth, and so I'm trying to sort of limit or constrain what we're going to be using Python to make it easier for you to use. With the caveat that I am taking liberties with the language, and I've now done a full explanation. There's nothing more to it here, but I don't think it's necessarily good programming practice to do it that way. So, okay. So, I think I have a longer, but not, I think it's relatively straightforward homework assignment. There's a back to it also, back as an example. So here, it's telling you to do stuff with global variables, so you get some experience with that. Okay, so that's due for Monday, so sort of winding down the semester again. So we have class Monday, of course, a week from today is Thanksgiving holiday, and again, a week from Monday, the 2nd of December, we won't be holding class in the classroom. I'll have a recorded lecture that I'll be posting to Blackboard at 8 o'clock on December 2nd, Monday, at 11 a.m., and there'll be a homework assignment then, and then after that, we're going to just have 2 more classes the following Wednesday and Monday, and I think that the final exam is 17th, and I said you guys can, the official start time is 10:10, but I'll be here at 8:30 if you want to start earlier. So, okay, I'll see you on Monday.